Thank you, Mark. Thank you. Very informative indeed. So a brief reminder for our participants to submit the questions, but I'm not even sure it's needed. There are many, many questions coming in, and I see Harry is already answering some directly in the chat. So then I will move to our next speaker, Mr. Dan Sârbenescu from Nuclear Electrica Romania. Dan is an expert on nuclear safety and risk at the Technical and Nuclear Safety Division at Nuclear Electrica National Company. He's a nuclear physics and nuclear installations graduate and has a PhD on nuclear engineering. He has more than 4 decades of experience in the nuclear field in construction, design, fabrication, and licensing at various executive and managerial positions. Half of them in Romania, connected with Cernavoda nuclear power plant, and half of them abroad as a PRA project manager of gas reactor, PMBR in South Africa, and as European Commission nuclear staff member in JRC Petten and DGNR in Luxembourg, with activities focused on safety and risk for nuclear and advanced energy systems. And Dan is currently involved in a large safety and risk projects at the company level, including SMR. So please, Dan, share your presentation. Go ahead.
Thank you, Nicoleta. Do you see the slides?
Yes, please. Go ahead.
So why did we choose to look for SMRs? In general, so we are connected with the nuclear field, and we have 2 operating CANDU 6 reactors, and the plan is to complete the construction of other 2 units in Cernavoda. And we also just CANDU, and we hold some part of the back-end part of the fuel cycle for CANDU. And we have a decision of the board to diversify the portfolio of activities. And in this context, the discussions about what can we do about the use of SMRs came up. So they came up in the context of evaluating the strategies for nuclear for the next at least medium and long term. So in this context, and considering the favorable situation for the SMRs in this moment, which is well known and was presented before by our colleagues, there is an interest for SMR, and there are a lot of things SMRs can do in order to complement the features of baseload type reactors as CANDU 6. So this is the goal, and I just explained in words what you see here on this slide. What is also mentioned here is the fact that we cooperate at national and international level in order to achieve our objectives. And we are connected to the national research programs too. But I'll come back to that. So the strategy for nuclear electrica on SMRs has the following parts. So first, it is included and it is part of the nuclear activities at national level. So we do have compliance with the National Nuclear Program. And that national nuclear program is correlated with energy strategy, which considers the phase out of West. We didn't start overnight this scrutiny on SMRs. It started a long time ago, but for us in this format in the last 6 years, and we started with some internal review of the possible sites to consider. And we consider there are 4 categories. There are existing nuclear installations. There are sites which were considered before 1989 for new CANDU plants. There are sites which are coal-fired plants and they are retired. And there are also sites of retired industrial complexes. And we consider that, and we had some our internal evaluations. So based on that, we got a grant from USTDA, And we had a contract with Sargent & Lundy in the United States, and I'll come back to that. So the next point here about the strategy on SMRs is the fact that we focused and we had as a strategy the view to have a gradual deployment of SMRs of various types. So, and the first point, the first step in that strategic approach is to choose a site and a vendor, a pair of sites and vendors, and start citing standard evaluations for, and after that to start to evaluate the sites based on the standards as they are, without any diminishing of the requirements for SMRs. So the next is to consider the first phase, in the first phase, water SMRs. By various reasons, I will not insist on that, but it is clear that at least for us to implement training and simulators for SMRs and to connect that with our existing training system in channel order and simulators and the whole system we created for a Canvas system. Then the next is to prepare for SMRs as a regional hub for us, and we work on that, oriented on services like operation, training, and other services. Then we would like to follow implementation of activities of the local supply chain. We did have a lot of development of our national capabilities to manufacture nuclear equipment, and we want to revigorate that. Then the next is to correlate these SMRs. They are not in competition. We consider them as a tandem with renewables programs, and we consider that, and I'll show how. Then the next strategy point is that we looked not on a plant, but on a fuel cycle. By the time we are going to build an SMR, we are going to have the second fuel cycle. The first is the Candu fuel cycle. Now, then we'll have the SMR fuel cycle. And we have a memorandum of understanding with our national research companies and an international consortium, Falcon, for a fast-reactor lead-cooled reactor, Alfred. And that will be the third fuel cycle. So then we are looking at the synergies of those fuel cycles and how to optimize the fuel cycle, because one nuclear power plant is at least 10% of the story. We have to look at the fuel cycle as a whole. And the last is that we don't stop on water SMRs, we look on all the SMRs and on the developments. So the activities are the following in order to do that. So there was an internal company initial and evaluation, and ongoing evaluations are still now. Then there was an interface with IEA for site selection. There were various contacts, there were meetings, and there is a plan for a detailed set of missions of IEA on this topic. And we look also in the first instance on the use of gradient approach for siting, which is an IEA specialized evaluation we are interested in. Then the next important issue to be mentioned here is the fact that yes, we did sign the memorandum of understanding with NuScale. So we looked at the capability and the status of licensing, and this was related to their achievements in the United States from USNRC. And we also have interface with them, and we have a teaming agreement with NuScale. We also supported our national regulator to get in and to increase the contacts based on the existing agreements with the USNRC, and we are in this loop. In order to proceed with those parts, we had a USDA grant, and based on that, we had Sargent & Lundy developed a study, and I will come back with more description about this. Coming back to our activities at the regional level, so we are active part in for-atom action. We have many bilateral international contacts for SMRs and a lot of non-disclosure agreements. We are aware of almost all the type of installations which were presented now in detail. But we cannot disclose that, we just know that. And we have a national cooperation on SMR from the point of view of deploying in our country, and the supply chain is very, very important. Now, as I said here, there are some details about our interface with IEA. It's not only those, there are not only those missions, it's participation in IMPRO, in regional training programs, and a CRP. By the way, the CRP is very interesting. It's related to emergency calculations for SMRs. Yes, they say it's not necessary, but in order to get license, you need some calculations and some more calculations to confirm many things. So we are in coordinated research programs calculating that with the IEA and with our regulator. So USTDA was of very high and decisive support for us in order to push this project. We got this grant, and Sergeant and Landy developed extremely thorough study, which considers all the sites we suggested, we proposed. We proposed a lot of sites in the 4 categories. They also considered vendors, diverse vendors, and they ended up with evaluations about suitability of the sites, considering all the detailed criteria as per IEA standards and USNRC standards related to siting. And the very useful study, it is going to be public very soon, and it helped us a lot. Then, of course, we have bilateral interfaces at European levels, as I mentioned. Why SMRs? I think I will not insist on that because it was presented before. Safety features, passive systems, modularity, there is flexibility in implementation, suitability of operation and construction. By the way, the licensing, a lot of licensing activities will move from the site to the manufacturer, a lot of them. So there's a huge difference by comparison to normal nuclear power plants. And then that's why there is a short on-site construction and much simpler commissioning period. In order to evaluate the site compliance and adequacy, so we are working on using IEA support and knowledge, for instance, in various ways, for instance, in using the graded approach, which is a graded approach, but without downgrading the requirements. So it's an approach which is based on the scrutiny, which things do not require so detailed evaluations and so costly steps every time for all the phases. And therefore, we can make our life easier in order to build an SMR. And that is in short some snapshot from their approach, which actually says what I said. It doesn't mean at all that the siting of the SMR will come somehow will try to get around the existing regulations. Not at all. Not at all. And then the status of SMRs for coal-fired plants. So the Sergeant and Landy study and our internal evaluations led us to the situation that we ended up with a list of preferred sites and vendors, these pairs, and the winner is the one you saw on media, is a NuScale with a site of a former coal-fired plant. And this is the announcement, which was done on the 24th of May in Bucharest on a USTDA workshop when this agreement was signed. And there was a presentation of the project. So there will be 6 modules of 77 megawatts on a former coal-fired plant. And these are the pluses of using SMR for a former coal-fired plant. And in summary, they say that SMR may assure, in this format, using more modules, may assure the conversion of coal-fired plants to green technology in not so costly phase, not counting too much on gas. Then SMR is timely and cost effective to be available within 1 decade. So that's our evaluation in this moment. And the more we get into that, the more we get confirmation and confidence that it is going to be so. And SMR has technologies advanced in being certified and available in this decade. So this is not the first of a kind. So the evaluation of the design by SNRC for NuScale, for instance, confirmed the fact that all the technical, the passive systems and the new safety features based on the post-Fukushima lessons. But the plant is not new from this perspective of the technical solutions. Now, related to the built on existing coal, on an SMR on existing coal power plant site, you see here a sketch here which is actually illustrating some things. Some of them are a bit, might be a bit of novelty for you. So you see in green what is an SMR. You also will see renewables. So we intend to use this tandem of a renewable plant, of a photovoltaic plant and an SMR on this site. Not just intend, so that's the plan. And we also have in mind the fact that together we will support the ecologization of the ash pond, which is close to that, and it is part of other projects. And yes, we use all those in yellow. You see all the things we reuse. So buildings, grid connection, surroundings, the environment, which also means part of the evaluations of the environment and the community. By the way, so in Romania there is no aversion to nuclear. On the contrary, as far as the communities are concerned, in this moment, we just got into a situation that we got invitations from many communities to build on their sites. And that's why building here and then using this brownfield, at least brownfield, that could be a value-added approach, and but it was mentioned before. Now, invitations from many communities to build on their sites. And that's why building here and then using this brownfield, at least brownfield, that could be a value-added approach, and but it was mentioned before. Now, this is a summary illustrating in a more schematic manner of these advantages. So, small land footprint, so it's around 10 to 15 hectares. That's for a minimal amount of the installation. Then we have modular construction, which is supported by the coal-fired plants footprints. We have benefit from existing infrastructure, water, grid access. Then we integrate that in the local urbanist zoning plans with benefits for local communities, ecological, tax advantages, social local workforce, and thermal power plant, from thermal power plants to nuclear plants, maintenance, construction, provide heating to the community, and provide other applications. So there will be a list of applications that will be potentially developed, as you know very well, hydrogen production, ecologization, and the last is build not only a nuclear plant, but an energy platform with renewables, and to use that also to help the ecological reconstruction of those sites. Usually, those sites have a high damage from ecological point of view, high social problems, economical problems, and nuclear is helpful. Challenges, of course, there are challenges. First is the licensing. It will be graded, but not downgraded. Then the next, yes, but it's not easy. So we are is helpful. Challenges, of course, there are challenges. First is the licensing. It will be graded, but not downgraded. Then the next, yes, but it's not easy. So we are in that now, and we can talk about that if questioned. It's not easy, but it's not impossible, and it's not a big issue. By the way, in Europe, it is important that we'll have in mind the European regulations and compliance with the Euratom and European directives, and we do have that in mind, and we don't have a gap in this moment as we identify so far. Then, yes, we are not a developer of technology, as you could see, at least for this material. For the fast lead reactor, we will be part of it, but for this, we are not developers, so we import a nuclear power plant. And this is not simple. So there are a lot of things to be solved in order to do that, and we are working on that, and there are no major impediments. Supply chain. So we want to build and to help our industry, and we are working on that, and we can do that. Various applications to be implemented. Yes, we have to develop, and as I mentioned, the first of all will be heat the communities, give electricity to the communities, support the ecological reconstruction of the area, and that's the first. I think it's quite enough up to 2035. And then we have to consider the fact that this is a plan that will be built for 6 years from now. So there will be many technological developments and many generations of people in 2080, for instance. So we'll have nanotechnologies, printing equipment, heat the communities, give electricity to the communities, support the ecological reconstruction of the area, and that's the first. I think it's quite enough up to 2035. And then we have to consider the fact that this is a plan that will be built for 6 years from now. So there will be many technological developments and many generations of people in 2080, for instance. So we'll have nanotechnologies, printing equipments, artificial intelligence. So when we are looking on the simulator to be built and the training program, we consider that. And the next is the financing. Yes, it's financing in another world, and with a little bit more flexible rules for financing than for big plants. And we have to adapt them to this present situation. And the last is, yes, we can use nuclear SMRs, then they beautifully can complement the existing nuclear power plant contribution to decarbonization. Personal opinion, whoever thinks that by renewables will solve this problem, I would strongly invite him to think twice. Thank you.
Thank you very much, Dan. So I encourage our panelists to answer the questions in the chat. There are many very specific questions in the chat, so please go ahead.